So the issue with flip-flops without a reset is that the output Q can be randomly assigned, which can make it harder to test upon startup. So what we'd like to do is we turn the system on and then we do a reset and set everything to a known value. So to do this asynchronously, we can just add an AND gate, and the way that works is if one of the inputs is always high, such as reset, then the AND gate will just give you whatever the other data signal is in. And so if I set this pin low, then this will be 0 no matter what, according to the AND truth table. And then upon the next clock cycle, Q will get that 0. Best, again, just to see it in simulation. So when the simulation started, it just automatically set Q to 1. That might not happen in a real ASIC unless you tell it to. The reset is high, right? And I can click that off and on, right? Which is also setting this to keeping it low, right? So if I put 1 here, okay, it's 1, I got a 1 output, and I press reset and it keeps setting it to 0. But notice Q is still that original 1. And if I want to pass D to Q, I can just advance the clock, right? Which now it's 1. I turn it off, and I advance the clock. I can do reset, and it doesn't change Q until I hit the clock. Now, it can be hard to see how this is asynchronous when I have to press reset and the clock at the same time. So it's better to let the clock run free, right? And see it's getting that 0 almost instantaneously because the clock edges are happening so fast you can't see it, right? Now I reset it, and Q just stays at 0 because that's where it was originally. So if I have 1, right, there it's high, and it's just continually reading that 1 because the reset signal is high. Now when I press reset, now no matter what the clock is doing, that output goes to 0, and then as soon as I let up on it, it reads in the next 1. So in this manner, I can set Q to some prearranged value, right? You could use an OR gate and configured in a different way.